We're in Unit 6, Lesson 12 today. We're going to be working on solving problems about percent increase or decrease. So we're going to use a variety of resources such as tape diagrams, equations, and reasoning to solve problems with negatives and percents. So the first item that I want you to put in your classwork today is this right here. So make sure this goes in the top part of your notes or your classwork. Percent change, and tape diagrams. Last lessons we've covered tape diagrams, and so today we're really going to hit home on percent change, which we explored in a previous unit. So percent change, we have our new value and we subtract our old value from it, and then we divide it by our old value. That will give us a decimal, and then we're going to multiply it by our 100% to get our percentage. If the result is positive, it's going to be an increase, and if the result is negative, it's going to be a decrease. So take a couple minutes, pause the video, and jot that down into your classwork, please. Now, as we jump right back into 12.1, 20% off, we'd have 1 minute individually. I'd give you some time as pairs, and then we'd go over it as a class. But the warm-up reads, an item costs X dollars, and then a 20% discount is applied. Select all the expressions that could represent the price of the item after the discount. Go ahead and evaluate these 6 expressions and circle the ones you believe would give us the 20% discount. And then once you do that, drop down below where I provide some sentence frames for you. I noticed that the expression or expressions blank, so I blank. Then if you're still confused about it, we'll go over this different scenario here. But right now, go ahead and pause this video and select the expressions that you believe represents a 20% discount. All right, now as you unpause the video and we're working through this, well, X is always represented by 100%. So we need to find items that will allow us to decrease that 100% by 20%. Well, the first one that does that is going to be number 2, because we have 1 right there in front of the X. We subtract the 20 over 100, and that's going to give us 80X or 0.80X, or technically in this spot it would be 80 over 100X, which could reduce down to 0.8X as well. Then the next one, number 3, would also work, because 1 minus 0.20 will give us the 0.8X that we're looking for. The 4th expression will also provide that for us, as we have it in fraction form, but the 100 minus the 20 here will give us 80 over 100X, which looks very similar to number 2. Then, of course, number 5 is exactly what we're looking for, in 0.8X. Now, this one doesn't quite work because we'd end up with 80X, not 0.8X. And then this doesn't work up top because we'd have 20 over 100X, which would technically be 0.2X. So what I'm looking for in the sentence frame doesn't have to be perfect, but I noticed that the expressions 2 through 5 represented 80% of the original price. So I selected them. Now, if you're still a little confused, we're going to break down the scenario a little differently below. So I'm going to switch to blue here. If you're still confused, use $10 for X to find the discounted price. So what is 20% of $10? Well, if you said $2, you'd be correct. Well, 10 minus $2 is $8. Now, if we wanted to look at this a little differently, we could have, what is 80% of $10? Well, if you wrote $8, you'd be correct. And that's the same thing as going 100% minus 20% equals 80%. And that's how we get that 80% right there. Here, we technically had our 100% and we subtracted the 20% to get our 80% right here, which was $8. And then down below, if you have 1x, you're subtracting 0.20 from it, you're going to get 0.8x, which we know 80% of $10 is going to be $8. Now 12.2, walking more each day. We have 5 minutes solo, 5 minutes with a pair or group, and then 5 minutes as a class. So Maya started a new exercise program. On the second day, she walked 5 minutes more than on the first day. On the third day, she increased her walking time from day 2 by 20% and walked 42 minutes. Maya drew a diagram to show her progress. Go ahead and let's look at these diagrams real quickly. We have day 1 right here. Day 2 where she walked 5 minutes more, so here's the additional 5 minutes. And then on day 3 she walked an extra 20%, which could be right here, that 20%. And she walked for a total of 42 minutes. Explain how the diagrams represent the situation. Well, I just kind of broke that down right now. There was the additional 5 minutes for day 2, the extra 20% for day 3, and the total of 42 minutes. And of course, we have our original value for day 1, which is represented by D. Noah said the equation 1.20 times D plus 5 equals 42 also represents the situation. Do you agree with Noah? Explain your reasoning. Number 3, find the number of minutes Maya walked on the first day. Did she use the diagram, the equation, or another strategy? Explain or show your reasoning. Then lastly, we have, are you ready for more? Don't worry about this one if it's taking you too long to get through number 2 or 3, but if you zoom past it, go ahead and try. Are you ready for more? She has been walking indoors because of cold temperatures. On day 4 at noon, she hears a report that the temperature is only 9 degrees Fahrenheit. She remembers that morning news reporting that the temperature had doubled since midnight and was expected to rise 15 degrees by noon. She is pretty sure that she can draw a diagram to represent the situation, but isn't sure if the equation is 9 equals 15 plus 2t, or if it should be 2 times parentheses t plus 15 equals 9. What would you tell her about the diagram and the equation, how they might be useful to find the temperature T at midnight? So go ahead, pause the video right here and work through these 3, and if you're finished early, go ahead and do number 4. All right, as we start back again, I want to apologize. I was saying Maya when it's my, so want to make sure that you know the proper pronunciation of the name. Now we explain how the diagram represents the situation. Well, we have D equals day 1, where D plus 5 equals day 2. And then we have the 20% or plus 20% equals the 42 minutes for day 3. Now, when we look at number 2, Noah said the equation 1.2 times D plus 5 equals 42 also represents the situation. Do you agree with Noah? Explain your reasoning. You could say yes, or you could say no, but make sure that your reasoning behind it follows one of these 2 lines of thoughts. So we could say yes. She walked 42 minutes on day 3, equal to 20% more than 5 more than day 1. So we could say that yes, because she walked 42 minutes on day 3, which is equal to 20% more than day 1 plus 5. So I'm just going to say day 2, which is D plus 5. Now you could also say that you disagree. And if you disagreed, you might have a different equation. Maybe you used a fraction form because there was 5 boxes originally right here. And then we added a 6th one to add the 20%. So if you wanted to use that as a fraction representing 6/5, and you wanted to use D plus 5, you're still going to get a 1.2 or 120% of the original value. And so we could work this out where that equals 42. And because the diagram was using fractions, you could have used this as your main equation. Now, number 3, find the number of minutes Mai walked on the first day. Did you use the diagram, the equation, or another strategy? Explain or show your reasoning. So if you use the diagram, I'm going to go right here, zoom in a little bit, diagram. Well, we know we have to start out with 42 right there. Well, if I start off with 42, I'm going to divide it by 6 because there were 6 blocks in that tape diagram. And when I go 42 divided by 6, I get 7. And of course, 7 times 5 equals 35. Well, why did I times it, or why did I multiply it by 5? Well, technically, day 2 is right here, and there are 5 boxes that encompass day 2. So I just multiplied it by the 5 boxes that represent day 2, and that's how I got that day 2 is 35 minutes. Well, once I have the 35 minutes, I know that I walked 5 less minutes in day 1, so I take my 35, I subtract 5, and I get my 30 minutes. So that's how I use the diagram to reason out how long I walked in day 1. Now, you could have also used the equation, and let's see here, and this is how you set up the equation. I'm just going to use the 1.2 times D plus 5. D plus 5 equals 42. Well, I need to divide both sides by 1.2. Then I get D plus 5 equals 35. And then I need to subtract 5 from both sides. And I get D equals 30. And luckily for me, both my answers match up. So I know 30 minutes is the correct answer. One way I did it with a balanced equation using the golden rule of algebra right here. And then on the other side, I used the tape diagrams to reason out how to find the number of minutes that I walked in day 1. Now, if you had time, if not, that's fine. Just follow along as best you can right now. So we did end up with the equation of 2t plus 15 equals 9. So the report, the temperature is only 9 degrees Fahrenheit. She remembers the morning news reporting that the temperature had doubled since midnight and was expected to rise 15 degrees by noon. Well, we know the temperature doubled It's going to raise by 15 degrees since midnight, and we're currently at 9 degrees. Well, if we want to find out how they might be useful to find the temperature at midnight, so we're going backwards trying to find out what temperature it is, and we need to be able to go subtract 15 from both sides, which gives us 2t equals -6. And then we divide both sides by 2. And move the equation up. Now we have t equals -3. So our answer would be -3 degrees at midnight. Okay, let's go ahead and move on to 12.3, a sale on shoes. Now, if we were in class, I'd break you off into our SLC groups. I'd assign each one of you a problem, or your group's a problem. You'd have about 10 minutes to double check your work, ask me if your problem's correct or your solution's correct, and then you'd make an SLC video and turn it in as a group. Today, just go ahead and work on it individually, working through these. I was able to find these math anchor charts from an amazing teacher in North Carolina, so I'm going to input those occasionally right here for you guys. If asked to find discount, if the price was this, $45, discount was 25%, you could either do 45 times 25%, which is $11.25, or you could go 0.25 and still get the same amount. But then of course you have the original, the discount, and you subtract the discount from the original, and you're going to get the new sale price of $33.75. That's kind of a refresher to be able to tackle problem number 1 right here. A store is having a sale where all shoes were discounted by 20%. Diego has a coupon for $3 off the regular price for one pair of shoes. The store first applies a coupon, so they're going to take $3 off first, and then they're going to take off 20%. If Diego pays $18.40 for a pair of shoes, what was the original price before the sale without the coupon? So we got to take these 3 pieces of critical information. We're going to have to work backwards, whether you want to reason that out or set up an expression. That's your choice, but that's what you're going to work on number 1. Number 2, before the sale, the store had 100 pairs of flip-flops in stock. All right, so they had 100 pairs of flip-flops. After selling some, they noticed that 3/5 of the flip-flops they have left are blue. If the store has 39 pairs of blue flip-flops, how many pairs of flip-flops, any color, have they sold? So we're going to have to take those pieces of information, the 100 pairs of flip-flops, the 3/5 of flip-flops they have are left are blue. They had 39 pairs of blue flip-flops remaining, and then how many have they sold of any color? Number 3, when the store sold 2/9 of the boots that were on display, they brought another 34 pairs from the stock room. If they gave them 174 pairs of boots out, how many pairs were on display originally? So we're going to have to use the 2/9, the 34 that they brought from the stock room, and then the 174 total to find out how many were originally on display. Number 4, on the morning of the sale, the store donated 50 pairs of shoes to a homeless shelter. They then sold 64% of the remaining inventory during the sale. If the store had 288 pairs after the donation and the sale, how many pairs of shoes did they have at the start? So we have to use the 50, the 64%, the 288 to figure out what was our original value. And then if you're ready for more, a coffee shop offers a special 33% extra free. So you could get a third more, or you could get a third or 33% off the regular price. Which offer is a better deal? Explain your reasoning. So right now, I want you to go ahead, pause the video, and this may take you 5, 10, maybe even 15 minutes, but I want you to make sure that you attempt each of these, and I'll be back shortly with the answer. All right, looking at number 1, the equation I set up, because I know 20% off is technically 80% total, so I went 0.8. And then I set up the parentheses with the original price being X, but I'm going to subtract 3 right away. And I'm going to set that to our total, which we paid $18.40. So that's how I use this critical information I pulled originally to put it into an equation to help me solve for the original value. Well, when I divide both sides by 0.8, 1840 by 0.8, I'm going to get x minus 3 equals 23. And then, of course, the opposite of subtracting 3 is to add 3, so I do it to both sides. And I find that x equals 26, or the original value of those shoes was $26. And I'll go ahead and put that right there. Number 2. This one gets a little bit more complicated, and you'll notice as they progress, they get a little bit more difficult. What I have here is 3/5 x minus, or 100 minus x. So I use the 3/5 right here outside the parentheses. I had the 100 pairs, and then after selling, we had 39. So there we go right there. And then what I did was I went ahead and distributed first on this one. Boom. And multiply that by that. So I actually ended up with, well, 3 times 100 equals 300 divided by 5. And that equals 60. So again, 3 times 100 equals 300. And we put that 1 underneath. So 5 times 1 equals 5. Well, 300 divided by 5 equals 60. So I'm just going to write 60. And then, of course, I'm going to subtract 3/5 x equals 39. Then when I come over here, I'm going to actually bump this up for us. I'm going to subtract this 60 first. So I end up with negative 3/5 x, and 39 minus 60 gives me a negative 21. Well, I'm going to have to divide both sides by 3/5, a negative 3/5, I should say. And we know anytime we're dealing with a fraction, we're going to have to go negative 21 over 1. We're going to keep change flip. So 21 times 5. And we end up with 105. X equals. And we would have, that's a negative there, so 105 over 3. And luckily for us, that reduces down to 35. Number 3, we have 7/9, because we take our 7/9 from right there. So 7/9. We're going to go x. We're going to add the 34 from the back, or the stock room. And then we're going to set that to 174. And first things first, we're going to subtract the 34 from both sides. We're able to do that because there's no parentheses. It's 34. I'm going to bring that up. So I'm going to have 7/9 x is equal to 140. And when I divide both sides by 7/9, I'm going to have to set it up with a keep change flip. So we're going to have 140 over 1 times 9 over 7. 140 times 9 is equal to 1,260. And then 7 times 1 is equal to 7. And 1,260 divided by 7 reduces down to 180. So our answer is 180 right there. Number 4, we're going to set up, well, we have 64%, which if you subtract 64% from 100%, we're going to get 34%. So I'm going to represent that in decimal format, 0.34. And then I'm going to take our x, and that's our original value. And then I'm going to represent the 50 pairs of shoes donated as a negative 50, or subtract 50 from our original. And then we're going to set it to a total of 288. Whoops, and I should have wrote 36%, not 34%. And as we go through that, I'm going to go ahead and divide first. 36, boom, 0.36, and I get x minus 50 is equal to 800. Well, the opposite of subtracting 50 is to add 50. So that's before we donated those 50 pairs to the homeless shelter. And we find that x is equal to 850. So how many pairs of shoes did they have at the start? Well, we had 850 pairs. Then we donated 50 to the homeless shelter. And then they sold 64% of the remaining inventory, which means that we were left with 36%. Are you ready for more? This one, it really depends. My original thought process is like, well, if I want more to drink, then I'm going to ask for the extra 33% and pay my normal price. The other part of me is like, well, if I want a little bit better deal, I want to go ahead and get my normal size and pay 33% less, but it also depends how much money I have. So this scenario, there's a lot of variables going on with it and what your preference is. But if you want to break it down to the unit rate, if you get your total right here and you're only paying for 2/3 of it, well, you're only paying 2/3 of the original price. Where if you pay the whole amount and we add on an extra, well, technically we're paying our unit rate. We've added an extra quarter on here, or a third, which means that we're technically at 3/4 is what we're paying for. So even though it's a discounted price, our unit rate is going to be about 75% versus 0.67 over here. So the unit rate right here is going to be a little bit better than it is over here. So as we finish up this lesson, we're our lesson 12 synthesis. So read through the summary first up here, and then this is going back into your classwork, and this will be part of your classwork grade. What have you learned so far in Unit 6? And then what do you still struggle with from Unit 6? This one really helps me. It'll kind of help guide our conversations on Zoom, or if we're in lunch tutorials, this would help guide me as a teacher to better be able to assist you. But both these are student choice. So go ahead and whatever you feel like you've learned or reinforced this unit, go ahead and put it right here. And if there's something that's really you feel like you're still struggling with, go ahead and jot that down right here for me. Then I want you to go ahead, pause the video, get those two things down. And when we unpause, we're looking at cool down, Unit 6, Lesson 12, solving problems about percent increase or decrease. So the track team is trying to reduce their time for a relay race. First, they reduce their time by 2.1 minutes. Then they were able to reduce their time by 1/10. So their final time was 3.96 minutes. What was their beginning time? Show or explain your reasoning. So I helped pull some critical information for you off to the side. Go ahead, pause this video, try to work out your cooldown. So as we double check the cooldown, we see that initially the track team was able to reduce their time by 2.1 minutes. So we have X representing their original time. We then subtracted 2.1 minutes from that. And then they were able to reduce that time by 1/10. Well, 1/10 is also 10%. So 100% minus 10% would be 90%. In a decimal form, that would be 0.9 or 0.9. And then we're going to set that equal to 3.96 minutes, because that was our final time that they provided for us here. So we took these three pieces of key information and we were able to plug them into an equation. From there, I went ahead and I divided both sides by 0.9, and 3.96 divided by 0.9 is equal to 4.44. So we have X minus 2.1 equals 4.44. Well, then you need to add 2.1 to both sides. And we find out that our original time for the team was X equals 6.5 minutes. There you have the answer for the cooldown today. Make sure you include the lesson 12 synthesis, this cooldown, and of course the key idea slash intro in your classwork before you turn it in today. All right, thank you very much.